My name is Heikki Linnakangas. I work for Pivotal, and today I'm here to talk about SCRAM authentication, which is a new authentication method in Postgres version 10. This is a feature I worked on together with Mikhail Pakir from VMware, who lives in Japan. So let's dive in. So what is this all about? So authentication has to do with the stuff that you put in your PG hba.conf. In previous versions, what you would typically put there if you wanted to do password authentication is this MD5 thing. SCRAM is now a new alternative to that. But first I'm going to talk about the MD5 authentication and these older mechanisms and what led to the conclusion that we need to have a new one. So there's plenty of authentication methods in Postgres already. There's the MD5, there's plain text password authentication, and now there's SCRAM. But there's also radius, LDAP, and PAM authentication methods, but on the wire, those are also actually using the plain text authentication. There are some other authentication methods like Kerberos and SSL certificates, but I'm not going to talk about them on today. This presentation is all about the password-based authentication method. That's what most people use in practice, even though the certificates and Kerberos are pretty good, and I recommend using them if you have a good use case for them, but in practice, passwords is what people use. If you have any questions at any point, just feel free to ask. That's always the best part of presentations. So one I didn't mention, there used to be a password-based authentication method called crypt, but that was removed back in 8-point-something, and that was an even older password-based authentication method, even older than MD5. So let's start with the normal or the simple plaintext password authentication. It works the way that the server asks the client what is your password, and the password gives the password to the server. And if the server thinks it's a good password, then it will let the client in. Now there's obviously some problems with this. It's obviously weak. If everyone is listening in on your connection, if there's anyone running a network analyzer or something, they'll just see your password. It's worth noting that this is what you get if you set radius or LDAP or PAM or BSD authentication method. That's what it will actually, on the wire, it will actually use the password, plain text password authentication. That said, it's actually the plain text password authentication is actually okay if you use SSL, because then it's all encrypted and it's not such a big deal that it's in plain text because it's within the encrypted SSL connection. So that's in that case it's not so bad. The MD5 authentication is a little bit more complicated. In MD5, the server will give the client 4 random bytes. It's called the salt. And then the client has to compute this MD5 hash, or rather 2 nested hashes of the username and password, and then the client responds to the server with this hash. And the server will do the same calculation, and if it matches, then it will let the client in. So the nice thing about this compared to the plain text password authentication is that you're not sending the plain text password over the wire. So if someone looks at this exchange, they won't get the password. They will only see these hashes, which are pretty useless, as they are as such. Now the reason there is this 4 random bytes, it's because if it was always the same hash, then the client could an eavesdropper could just get the hash and use that to log in. But there are some weaknesses with this. The first problem is that it's pretty easy to guess these passwords because the MD5 hash is very cheap to calculate. I ran a little experiment on my laptop, and my laptop could do about 7 million MD5 hashes per second on a single core. This was a pretty straightforward implementation. I'm sure you could optimize it more by using GPUs and, of course, more powerful CPUs and so forth. So you can easily make a lot of guesses of MD5 hashes. So if you have a dictionary, or you can even try to brute force a short password, it's quite feasible with MD5 hashes. So that's the first problem. The second problem is that even though there is this 4-byte salt, it's not long enough. It means that there are only about 4 billion unique salts, and that makes you vulnerable to what's called the birthday attack. It means that if someone is listening in on these authentication exchanges and you capture maybe about 1 million of them, there's a pretty good chance that the next time that you try to log in, you will see one of these random values that you've already seen once, and then you can replay the response that you already seen. So if someone is listening in on your connection and you do a lot of connections, that's a big problem. Or if they can somehow force the client to disconnect and reconnect, you can induce the client to do this faster. Third problem that not a lot of people probably realize is that you don't actually need the original password to log in. What the server will store with MD5 authentication is this inner hash of the MD5 hash of the password and the username. And that's what the server will store in the database for each user. But that's all you need to log in. You don't need to know the original password, because if you have this inner hash, then you can calculate this outer hash for any salt. PG Bouncer and PG Pool 2 actually take advantage of this, and it will download all of the MD5 hashes from the catalog table and use that as a feature. But it's generally considered a security issue in that if someone steals your backup, for example, they will get all of these password hashes for every user, and they can log in as any user, basically. It also means that you should treat the role password field as if it was plain text passwords, because that's all you need to log in. In one sense, it's actually more secure to use plain text password authentication, because if you use plain text password authentication, then you need the actual original password and not just the hash. But that's a bit off topic. There are some other issues with MD5 authentication. One is that because the hash calculation includes the username in there, it means that if you rename a user, the hash isn't valid anymore. So whenever you rename a user, the Postgres will reset the password for that user, and it will give you a notice about that. So it's not probably a big deal in practice, but it's kind of annoying. Another issue is that there is a feature called DB user namespace, which would allow you to have users per individual database and not just global users across all of the databases. But that feature doesn't work with MD5 hashes or MD5 authentication because of the same reason. The username that you would log in is not the same, would not be the same username that's stored in the catalog table. And third, last but not least, MD5 has a bad reputation. It's kind of, if you Google for MD5, you will get advice that you should not use MD5 because it's an old and broken algorithm, which is true. It's actually okay for our purposes as a hash algorithm, because the authentication relies, all the known attacks for MD5 are collision attacks, so it's very easy to generate two files that have the same hash. But there are no feasible attacks that would let you to get the original password or find another password that would give you that exact same hash. So for our purposes, the MD5 as an algorithm is actually okay. But it's still annoying because we actually get requests or comments every now and then on the mailing lists and on the security mailing list too, saying, why are you using MD5? That's broken. And then you have to kind of explain that, yeah, we know it's kind of broken, but it's for our purposes, it's actually okay. So it would be nice not to need to have that discussion in the first place. But that's really just an image issue, though. These other weaknesses are the real problems with MD5. So that's why we decided to add a new authentication method to eventually replace MD5. and it's called SCRAM. It's defined in these RFCs. If you Google for them, you'll find the specifications. It's a challenge response, like a method like the MD5 authentication, and it stands for Sorted Challenge Response Authentication Mechanism. To be precise, we implemented a variant of that called SCRAM SHA-256. The original plain SCRAM protocol uses SHA-1 as the hash algorithm, but otherwise it's exactly the same. We just decided to go straight to the SHA-256 because it's more modern. Might as well skip the SHA-1 implementation. So the SCRAM authentication looks like this. You have the client. The client first sends a little random string to the server, and the server will reply with a longer random string and a salt and then what's called an iteration count. And then there's some little bit more complicated calculation where the client computes from the original password and the information from those from the previous step. And there's a nice fourth step here that's completely missing from the MD5 authentication, which is that the server will also calculate a different hash and send it back to the client. And the client can use that to verify that the server also knew the password. So with SCRAM, you not only authenticate the client to the server, but you also authenticate the server to the client, which is pretty clever. Now there's some caveats on that. It's not actually very useful for Postgres at the moment, because in Postgres, or the libbq implementation of the client, there is actually no way to force SCRAM authentication. So if you have a fake server, this fake server can just request you to do plaintext password authentication, and the client will happily just give away the password. So that feature is actually kind of useless for us at the moment, but that could be fixed easily, and we should and will fix that. So this improves over MD5 in that it's more resistant to dictionary attacks. The hash that you have to compute in this is a lot more expensive than the simple MD5 hash. You saw that there's this iteration count that's about 4,000. It means that you will have to do 4,000 SHA-256 hashes for every time you log in or every time you try to guess a password. So this makes it a lot more expensive to launch a dictionary attack where you just try to guess the user's password. You should still use long passwords and choose them randomly. It's always a good advice, but it's much better with SCRAM than it is with MD5. The other fix in SCRAM is that it uses these much longer random strings as part of the exchange compared to MD5. So the replaying or capturing these authentications and replaying them later is not a problem anymore. There are so many of them that it's not feasible. Each authentication is basically unique. And third, the verifiers that you store in the catalog table, you can't just use that hash to log in. It's a one-way hash that you have to work to launch a dictionary attack or something if you want to use it. You can just take the hash and use that to log in, which is great if you have your backup stolen. The passwords stored in the database, you can't just use them. As I mentioned, that's also a problem for some of these tools that were taking advantage of that, but that will need to be fixed. So SCRAM is a pretty simple algorithm. The implementation in libbq in the client, it's about 1,000 lines of code, except for some pretty long tables for Unicode normalization, which is part of the spec, and we have to implement. But it's just like a lookup tables. And it only relies on the SHA-256 hash function. There is no complicated math like there is in some other authentication methods. You don't need like long integer mathematics. You don't need exponentiation or factorization or anything complicated like that. All you need is the SHA-256 hash function. And that's a very simple to implement from scratch if you have to, but most likely all of these modern programming languages, you will have a built-in implementation of that anyway. So that was an important factor in choosing this, that because this needs to be implemented both in the server and the client to do SCRAM authentication, it's important that we will actually get these implementations done in all of the different drivers. And like the JDBC driver, ODBC driver, all of those need to support this thing. Well, ODBC uses libpq nowadays, but all of the Python drivers and so forth. So how do you use this thing? If you want to switch to using SCRAM today, the default is still to use MD5 when you create a new password, but you can change this configuration setting in your config file or just for a single session if you want to play with it. It's called the password encryption. We reused, there used to be a password encryption option in previous versions too, but it only had two values, on or off. And the off used to mean that the passwords are stored in plain text in the server. We took the off option away, so in Postgres 10 they will always be hashed with either MD5 or they can now be hashed using the SCRAM SHA-256 algorithm. So it's no longer a Boolean, it's now a enum option where you can specify MD5 or SCRAM SHA-256. We still accept on as an alias for MD5 for backwards compatibility, so if you have old configuration files lying around, they should still work. So if you create users, you will see the hashes. Even in previous versions, you would see these MD5 hashes in the catalog table. If you create a user with the SCRAM hash, you will see something like this, where you have the identifier in the front which says that it's a SCRAM password or SCRAM hash, and then you have the salt and the iteration count and the information needed for the authentication. Any questions so far? No? Okay. Straightforward stuff. So just in case I wasn't clear, whether you can use MD5 or SCRAM authentication, it's per user. You can only have one password for a user, and the password is always hashed either using MD5 or SCRAM. So if you create a user with the MD5 hash stored in the database, then that user can't use SCRAM, it has to use MD5. And likewise, if you create a user with the SCRAM password, then that user always has to use SCRAM authentication. So you should only make this change to SCRAM after you know that the clients will actually support SCRAM, because otherwise they can't log in. So for compatibility reasons, if you put MD5 as the authentication method in hba.conf, it actually means that it will allow MD5 or SCRAM for those users that already have a SCRAM password. So the way to upgrade or the way to migrate to SCRAM is to keep using MD5 in your hba.conf, but change the password encryption setting so that every new user or whenever someone changes their password, they will start to use SCRAM from that point on. And there is an option that you can set in the hba.conf SCRAM SHA-256. That means that you will not accept MD5 authentication from those hosts. So if you have a user that only has an MD5 password or MD5 hash of the password, then that user can't log in. Sorry? Yes. So, well, no, you can't. You can't change. You can't turn an MD5 hash into a SCRAM hash or vice versa. So if you do this, if you do set password encryption to SCRAM SHA-256, and then you do alter user to set the password, then it will be hashed using SCRAM. But you can't change the passwords of existing users from MD5 to SCRAM, unfortunately. It requires you to reset the passwords. So one thing that came up with the implementation, SCRAM is actually just one authentication method in the family called SASL. SASL is another specification for creating new authentication methods, and there are, in addition to SCRAM, there's a few others. It's a strange protocol. When I first started to read up on this protocol, it's, as it says there, it's a framework for providing authentication services in connection-oriented protocols via replaceable mechanisms. So it doesn't specify very much. It says that there are these authentication mechanisms, and it says that there are these connection protocols. In this case, the connection protocol would be the libbq protocol, and the authentication method is SCRAM. And the specification just says that there, in your protocol, there's got to be a way to send these authentication messages, and it's up to you to define how you send them in your protocol. And then it says that it's also pluggable how you do the authentication. So there are these other specifications for your authentication mechanisms that send these messages. So it's strangely very generic, but it allows you to decouple the implementation of the authentication mechanism from the protocol that you work on. So for example, there's been implementations of SCRAM in MongoDB, as far as I know, and some other systems as well. But the way you send the messages, the exchange of the hashes back and forth is different for each protocol. Like it's different for libbq. In libbq, we wrap them around what we call password messages going back and forth. But in, say, MongoDB, it would be, I don't know how they work. They pass the messages in a different way. So it's actually pretty clever. This is the way this is implemented. You have decoupled the authentication method from the way you use that in the protocol. In Postgres, there is only one. There is only SCRAM. But using the SASL framework, you could easily plug in new authentication methods. So part of the work that we did with SCRAM was to implement the negotiation of the authentication mechanism. So if in the future we add new authentication methods, it's going to be easier because there is already in place this way where the client and the server can negotiate which method do you use. That wasn't there before. It's very simple. It used to be very simple where the server just tells the client what to do, but now there is actually a way to negotiate. Another nice thing about SASL is that there can be, and there are, external libraries that implement SASL mechanisms. Like there is libsasl from the Cyrus email server project. I'm not sure if they support SCRAM, but they certainly support other SASL mechanisms. So in the future, we could possibly link one of these libraries into Postgres, and you could immediately be able to use any of these other SASL mechanisms without having to add extra code to Postgres itself. I don't really foresee us doing that. I don't see much need to do that, but it's a possibility. It's also nice for the clients because if your programming language or framework already has support for SASL, you might be able to just find an existing implementation and not have to write this thing from scratch. Although SCRAM is a very simple protocol, so it's not hard to write from scratch, but you might be able to avoid it. So this is what we have in Postgres 10, the SCRAM SHA-256. There are a few things that are missing or implemented differently than you might expect. We don't do what's called the channel binding. I'm going to talk a little bit more about that later. Another interesting detail of the way we've implemented SCRAM is that in the SCRAM exchange, as part of that exchange, the client sends the server the username. But we don't use that in Postgres because in Postgres, the client already has sent the username earlier in the authentication. That's the very first thing that the client does when you connect with libbq. It will send the server the username. So we don't need the username as part of the SCRAM exchange at all. So what we do is that the client will always send an empty string as the username. And that basically means to the server that you already know the username, don't bother with that. So another way to do this would have been that the client would send the same username again, but there's a little problem there because the SCRAM specification says that the username is in Unicode, in UTF-8, but Postgres is more flexible than that. We don't say anything at all about the encoding used for the usernames, which is a bit of a problem actually, because it's not well defined what the encoding you're using for these usernames, but there it is. So not necessarily all the usernames are in Unicode or can't even be converted to Unicode. So it's better that we just leave it empty. So as I mentioned, the way you migrate to this is that first of all you have to make sure that all of your clients support SCRAM. You have to have a recent version installed everywhere. In libbq, this is now included in Postgres version 10. So if you're using a libbq-based client, upgrade to Postgres 10. If you're using something else, like Python or Java or whatever, make sure that you have a recent enough version of those libraries that they support SCRAM before you start to change your passwords, because otherwise the clients can't log in. And the next step is to set password encryption to SCRAM in the PostgreSQL.conf file. And the third step is that you have to reset all of the passwords of all users. You don't have to do that immediately. You can just keep it running and let your users have their MD5 hashes for as long as you want. But the next time they reset their password or change their passwords, they will get SCRAM passwords. You can later go into the and look at the PG auth ID catalog table to see which users have already migrated over, and maybe after a few months or a year or something, you might want to go and reset the remaining passwords for those users that haven't changed them. Finally, remember that this is all about authentication. Authentication will not do, even SCRAM won't do encryption of your data or the connection. And so you really should still use SSL even if you switch over to SCRAM, because you do want the connection to be encrypted anyway. Otherwise anyone can read the data as it flows, or if there's a man-in-the-middle attack, they can just change whatever happens after the authentication, even if SCRAM is secure. So I think in the near future, what we're going to do, the main focus is going to be on implementing the SCRAM in all of the client libraries. libbq has been taken care of in Postgres 10, but JDBC is still on the way. Yeah, how's it going? Huh? It's just pushed, as in 5 minutes ago, before you entered the room. Good timing. In 2 releases?
We're going to do 1 release before, and we're going to then a snapshot.
Cool.
And
Good timing. So JDBC driver has been taken care of. There will be a release very soon. After that, we need to get all of these other drivers. So if there's anyone in the room who's maintaining a driver for Postgres, for Python or Ruby or whatever, now is a good time to start writing the support for SCRAM, because as soon as the Postgres 10 is released, there will be users trying to use it. So I'm really looking forward to get support in .NET and all of these weird drivers out there. Another related thing is that PG Bouncer and PG Pool, and there's probably other middleware like that, connection poolers, that also speak the libbq protocol and connect and accept connections from the client. They really should also start to support SCRAM, so someone needs to write support for this in all of these middleware tools. And then there's that little thing I mentioned in the very beginning, is that currently there's no option in libbq to force SCRAM. So if you have a man-in-the-middle attack, you have a fake server. This fake server can just ask the client to do plaintext password authentication, or they don't actually need to do any kind of authentication. They can just let the client in and do whatever evil stuff you want it to do. So we really should add an option to libbq to force it to use SCRAM, so that the client won't just give away the password to anyone who asks. That would also be nice to do in the other drivers, although I They might be actually smarter than libpq about that, but maybe not.
I don't think they are.
Yeah. Yeah, it would be good to fix that in all the other drivers too then. Yeah. So the last bullet point, channel binding. There was this feature that we didn't implement yet. It's part of the specification. It's an optional feature, so it's okay that we didn't do it yet. If you're using SSL and you enable channel binding, or both the client and the server supports channel binding, you essentially take some parts of the SSL handshake and include that in the hash that you call calculate when you do the authentication. And that's really nice, because that has the effect that if you try to do a man-in-the-middle attack, in that you have a fake server and it uses SSL, and the client connects to that, and then you try to open another connection to the real server and just sit in the middle, the authentication will actually fail, because it will notice that the SSL connection that the client is connected to and the SSL connection, the endpoint for the real server, they belong to a different SSL connection, so you'll notice that. And this is essentially a replacement for having a CA certificate installed in the client, because you will detect a man-in-the-middle attacks. If you have the CA certificate and you use the SSL mode verify or verify full, that also defeats the man-in-the-middle attack, but it's kind of inconvenient that you have to install the certificate in the client. With the channel binding, that will no longer be necessary, because the SCRAM will also do the same thing, and it will detect any man-in-the-middle attack. So you will no longer have to fiddle with the SSL certificates in the client side. All you need is a good password, and that's good enough. That's enough to make the connection secure and authenticate the client to the server and the server to the client. So that's going to be a nice feature. There's a patch by Mikhail Pakir for Postgres 11 already out there, and I'm pretty sure we'll get it into the next version, Postgres 11. So yeah. In the long term, there's some more stuff we can do. For example, it would be very nice if you could also use SCRAM authentication with LDAP, with radius. I mentioned in the very beginning that if you use LDAP authentication, the client will see it as on the wire, it's going to be a plain text password authentication. The only difference is that the server will ask the LDAP server for the password instead of storing it in the database directly. But there's no fundamental reason you couldn't store the SCRAM hash in LDAP instead of the plain text password. And if we did that, then it would be possible to use LDAP authentication with SCRAM. And that would be really cool. There's no reason you also couldn't do that with MD5, but we're kind of probably not worth bothering with that anymore at this point. Then there's this little thing I mentioned earlier as well, that the PG pool and the PG bouncer rely on the bug or feature that you can take the password hashes from the catalog table and just use them to impersonate any user you want. Now that SCRAM fixes that problem, now these middleware tools that we're taking advantage of, they have a problem. So if you have PG bouncer sitting in the middle, you can't really use SCRAM going from the client to PG bouncer and from PG bouncer to the server, because it's going to be, in that scenario, PG bouncer is effectively acting as the man in the middle, and the SCRAM authentication is designed to make that impossible. So we'll need to have some kind of smarts to fix that. One idea is that maybe we'll add a feature to the server so that you can have another user or something where you can delegate the authentication. So PG bouncer would maybe have just a single username and password, and it would know that using that you can log in as any user or something like that. But we don't really know yet what we're going to do about that. We'll see. If someone has good ideas, that would be nice. So there's another class of protocols called the zero knowledge proof protocols. I briefly looked at this before I started to work on SCRAM and considered, for example, an algorithm or protocol called SRP, Secure Remote Protocol or something like that. But there's many other similar ones, and this is kind of an active field of research still. But there are these algorithms where the zero knowledge proof means that if you're listening in on the authentication and you see all the messages going back and forth, where the client connects to the server and you calculate the hash, with these new protocols, even if you see all the messages going back and forth, the attacker will not get any useful information that you could use to guess the passwords. With SCRAM, if you have someone eavesdropping on the connection, you will see the hashes going back and forth, and using the information you see on the wire, you can start to try guessing the passwords. So if you see any authentication, you can start to guess the passwords using the hash that you captured, which means that you should still use strong passwords. But with these zero knowledge proof protocols, you don't have that problem. So with a modern protocol like that, you could use weak passwords, like 1, 2, 3, 4, 5. Well, maybe not that weak. But you could use shorter passwords safely, as long as you then have like a rate limiting or something in the server, or you lock the account after a few tries. That would actually, with a protocol like that, that would actually be safe. So that would be very nice. The downside of that is that this is, as I said, it's still research is going on in these algorithms. So I wasn't really comfortable switching over to something like that, knowing that it might be broken in a couple of years when someone comes up with a good attack on them. Also, there has been patent issues with SRP in the past, at least. I think it's not a problem anymore, but there used to be some ambiguity on that. And also, there isn't a good specification, like there isn't an RFC that we could just directly follow for any of these, like there is for SCRAM. Another problem with these more better protocols is that they are also a lot more complicated to implement. With SRP, you need to do it's like public key encryption. You have to do complicated integer mathematics and so forth. And if you're writing this thing from scratch in C, for example, it's kind of complicated compared to just having a hash algorithm. So that's why I didn't choose one of these newer algorithms. But maybe we will have that in the future as well. Any questions? I am running out of material. Is there? No? Okay. That's all I have. Thank you.